Okay, for the next step, let's simulate the wind load on this structure. So let's see how the forces exerted by the wind loads in X and Y direction axis affect the overall stability of this building, right? And how to check it first of all. So if you wanna check the effects of the wind load on this structure, you have to go on loads, all right? And from here, you need to pick the wind load simulation, and then after that, you need to generate the wind load structure, the wind loads, right, on this structure, all right? So you need to understand something here. All right. Oh, sorry, it's taking a little bit time. All right, so here we have components in X and Y direction, right? So in X direction is when the wind load forces, they're acting horizontally along the length. This is the length of the building, right? And in Y direction, those forces, they're acting also horizontally, but across the width of the building, right? This is the width of the building, right? This part here, this part, right? So here I can divide this this component here into two, right? In Y direction and X direction. I can just pick 4, right? I can, but since I have the wind pressure, so wind pressure is the force of the winds, of the wind loads, right? It's the force, right, of the wind loads. So since I have the same magnitude, the same forces of these winds here, so I'm gonna just pick, I will pick all, I'm gonna check all of them at the same time. So here for the wind pressure, I will pick 1.0, right, kilonewton meter square, right? And also for the terrain, like for the land ground, land ground, right, I'm gonna pick, let's say the surrounded building, the neighbor building, right? There are 2 meters, right? So I'm gonna just pick 2 here, but it can change according to your projects, right? I'm gonna pick 2 here, right? So, and for the element, for the wind exposure, I'm gonna keep the way it is here right now. And for the component, the wind direction, I'm gonna pick all of them at the same time. I'm gonna pick all of them at the same time because they have the same wind pressure, right? As I said before, right? But if they have different, if X and Y have different wind pressure, you have to take them separately. So you have to pick 4, right? So, but I'm gonna check all of them at the same time, and I will go on load cases here, and I will pick winds in X and Y direction, right? So I define my loads like in X and Y direction, right? So I'm gonna simulate these forces under this load case, and after that I'm gonna start the simulation automatically, right? So I'm gonna just press on start, right? So the terrain is more important. Like, what if you're not simulating the wind load on a structure, you have to make sure about the terrain level, right? The land ground, right? So after making sure about all the value that you need to input for the wind load, you have to start simulating, right? Just press on start, and then after this is gonna be our simulation process. It might take a long time, right? So I'm gonna see after all of this simulation here in meshing simulation in X plus, the loading generation in X plus. After all of these components being checked, I will see you again. All right. As you can see, the wind simulation is completed, right? So all of the possibility of our wind direction, they've been verified, they've been calculated, right? So as you can see here, this is the information from the software that the wind simulation has been completed. So I just want to press OK, right? And here I can just close the table because I don't need to import any components here because I check for all the components at the same time, right? So I'm gonna just press close, right? And here, this is how our building look like. Like, this is how the wind affects our building, right? The reds, as you can see here, like yeah, this is how the wind affect our building, right? So in every direction, and so the overall stability of structure is been affected by the wind loads, right? So if I wanna check the value of the wind load, right? You can just come here, right? And you can see that main load has been created automatically by the computer. Like we have the wind load in X direction, we have the wind load in X and Y direction, like X plus positive X and positive Y, and we have the wind load in positive Y direction, and also we have the wind load. So we have the wind load in different direction, right? So this is how we can check the value, and all the value, the frequency, like the value, the pressure of the wind load is 1 kilonewton meter square, right? And if you go on load, all right, and you go on load table here, load table, all right, yeah, from the load table here, right? If you wanna check the value, the exact value of the wind loads, so you can see if you open here, right, from this part here, from this row here, you might see that this is the list, right? This is the case, the wind load in X and Y direction. I put them in one load cases in the previous in the video, in the beginning of the video. I explained to you how and why I put it in one file, because they have the same magnitudes, right? They have the same wind load pressure and the uniform loads, of course, right? And the most important is the force in the Z direction, right? We can see the pressure, they have different pressure, like the pressure is changing, right? It's very, right? Like we have 0.03, right? And it's changing, right? So this is how we can check the value of this is how we can check the value of the wind load. So there are a lot of value because wind is complex, right? So a lot of value. This is how we can check the value of the wind load on the structure, right? So this is the all process that we have to do to simulate the wind load on the structure. And don't forget to share the video, and don't forget to like the video, and don't forget to subscribe to this channel. I'll see you in the next one. Bye bye.